Alright, it's factorization again, and this time around we're going to be taking a look at factorization of simple or large algebraic expression. I told us factorization cut across a lot of topics in mathematics, and you just need to full of the understanding of how factorization is used. So in this unit 2, these are our set out objectives. By the end of it, you should be able to find the HCF of algebraic terms, okay, and you should be able to factorize simple algebraic expression. Thirdly, you should be able to factorize large algebraic expression. So what makes it simple you will know, and what makes it large algebraic expression you will surely know by the end of this lesson. Alright, you are welcome, stay tuned and relax, because you have a lot to do. And I will enjoy you to please, if you don't have any basic idea about factors of numbers, I will implore you to get the unit 1 of this video. Touch broadly about factors of numbers. You will actually need it here. You may need it here. Alright, we'll continue by taking a look at the simple and large expression. So we are taking a look at the HCF of algebraic terms. So first we are starting by looking for the HCF of 15x and 20n. So how do we get this? If you remember in unit 1, there is a method we use, prime system, where we express numbers as product of prime. So that is going to be very important. That is the system we're going to be using ahead. So if you don't understand, please go back to unit 1 or go and watch my video on expressing number as a product of prime numbers. So to start with, I'm having 15x and I'm having 20n. So let's express 15x as a product of prime. So that gives 3 by 5. Then I'm left with x multiplied by x. So 3 times 5 times x gives 15x. Alright, let's work on 20. Expressing 20 as a product of prime gives 2 by 2 by 5. Then multiply by the n that I'm having here. Okay, so what do you think is the next thing now to do? This is a 3. There is no 3 here. So I can't pair this 3 with any other thing. This is a 5 and there is a 5 here. There is a 5 here, there is a 5 here. So there are this single pair of 5 that are common is enough to make my HCF. So the HCF of 15x and 20n is 5. Let's take more examples for better understanding. Now I'm having the same set of numbers, 15 and 20, but now I've changed the alphabet. So here I'm having 15. 15 is expressed as 3 times 5. Now I'm having p q squared. I'm having p q squared. So p q squared is expressed as p multiplied by a q and another q. A q and another q, because here I'm having q squared. So the same thing, 20. 20 is expressed as 2 by 2 by 5 in prime. Now, breaking p squared q down, I'll be having p multiplied by p multiplied by q, because I'm having square on p. So that's why p is repeated twice. Here I'm having square on q, that's why q is repeated twice. So the numbers first. 5 is common, just as it is there. 5 is common, so I can write out my 5. Now I have a p here, I have a p here. Yes, so there is a red p here, and there is another, there are 2 groups of p here. So I can just match this with this to give this p. Now this is a q and this is another q. This is a q and this is another q. So that is making a q. Now this q has no other q to match up with. And this p has no other p to match up with. So I can't do another thing beyond this. So multiplying out, my answer will be having 5 by p by q. So that's 5 pq, and this forms my answer here, 5 pq. Okay, I believe that is understood. So let's move forward, and I'm having 11v squared w and 22v cubed w cubed. Let's see how that works. So I am expressing 11 as a product of prime. What do you think that would be? 11 itself is a prime number. 11 itself is a prime number. So expressing 11 as product of prime is just 11. It's just 11. Or you say 11 by 1, and there's no point in using 1 here. You don't need 1. So here is 11 multiplied by my v square gives v by v. That's v in two places, and I am having just 1 w. Then next is 22. 22 is expressed as 2 by 11. Then multiply by, I'm having 3 v's. Because here I'm having 3 on top of v. So it's going to be expressed as v by v by v. And this is w. So I'll be having 3w. I'm having them here in red. So what's the next thing? Let me deal with my number first. Dealing with my number first, I'm having 11 and 11 here. That's the only thing I have in common with the numbers. Now, pairing my alphabets. Here is v and another v. Forms this v. Gives chance for this v. Here is another v and another v. Gives this v a chance. Now this is a w and this is another w. Then gives this w a chance. There is no any other thing I can pair together again. Everything up here is just paired up. So I'm having, because of that, I'm having 11v squared w. That is the solution to my answer. Now, 4. I'm having 25am plus 10dm squared. So 25am is expressed as 5 by 5 by a by m, and 10dm squared is expressed as 2 by 5 by d by m by n. I just want to believe you understand what I'm doing now. I don't need to stress anything anywhere again. So I'm having 5 and 5 here. This is a 5, this is a 5, and I think a m. This is just a 5 and a m. So that should give me 5m. Yes, that should give me 5m. And that's my answer. Alright, now for number 5, I'm having 72pq squared and 90p squared q. So 72 is expressed as 2 by 3 by 3 by 4. I'm having p squared q squared expressed as p multiplied by q. Now this is 90. 90 is expressed as 2 by 3 by 3 by 5. And I'm having p squared expressed as p by p and q. So I'm having a 2 and a 2 here, represented here. I'm having a 3 and a 3 here, represented. I'm having another 3 and 3, represented. This is a 4 and this is a 5. They are not matching. They are not matching. So this is a p and p matching. This is a q and a q here matching. No any other thing matches another. So my HCF is multiplying everything here out. This is 2 by 3, that's 6. 6 by 3, that's 18. Then 18 by PQ, that's 18 PQ. Alright, I need to be fast here. This is 150 squared and 225 V cubed W cubed. Okay, so expressing 150 as a product of prime, what do we have? We have 2 by 3 by 5 by 5. Yes. Then expressing the alphabet, breaking down the alphabet, that's going to be V squared, that's V by V, and W squared is going to be W by W. Now, expressing 225 as a product of prime, I'm having 3 by 3, 5 by 5. Yes, if you break it down, you will have this. So, expressing my alphabet, that's going to be V cubed and W cubed. Yes, that's V cubed and W cubed. So, pairing up what I'm having a 3 and a 3 here. So that is giving 3 an automatic selection already. So I'm having a 5 and a 5 here. I'm having another 5 and 5 here. So that's why you're having 3. Sorry for that confusion. That's why you're having a 3, a 5 and a 5. I'm having a V and a V, another V and V. I'm having a W, a W, a W, a W gives this, and WW gives this, WW gives this. Then we have all together 3 by 5 by 5. That is 75. Then V by V, that is V square. W by W, that is W square. I'm sorry, I have a shortage of space. That's why I have to do it that way. So Going for simple expression. We want to factorize the following expression. How do we factorize 10? Let's start with A. Our A, we are having 12n plus 16n. 12n plus 16n. So you just need to ask yourself, what is common between 12 and 16, 12m and 16n? The meaning is that what is the highest common factor of 12 and 16? You start like that. And I've taught you the highest common factors of numbers. So what do you think it is? 2 is a factor, but is it the highest? No, it's not. 4 is a factor, but is it the highest? Maybe. So 4 is just the highest common factor of 12 and 16. And that is why you are seeing a 4 here already. So the highest common factors of 12m and 16n is what? Is 4. So that is why you are seeing a 4 here already. And the next step is that you bring out this 4. You write out your 4 here. And you open the bracket and have this inside. So here we're having two terms. We're having 12m and plus 16n. You divide both of them by the 4 you write out here. So that's going to be 12m divided by 4 and 16n divided by 4. Least you're having a 4 here and a 4 here. So just do your division. So you are left with 3n, then plus 4n. When you remove this bracket, you will have what you have here back. Alright? You're definitely going to have it back. So let's proceed. For B, we are having 8y plus 8y squared. We are having 8y plus 8y squared. So how does this work? You look for the HCF of 8y and 8y squared. So what do you think is common to both? That is 8y. Just like you've seen it. So what do you do now? You bring out this highest common factor, which is 8y. Then you open a bracket and have this inside. So the next thing you want to do is you want to divide each of these terms by 8y. So this is 8y divided by the 8y you have outside, and 8y squared divided by the same 8y you have outside. So you divide each of the terms inside the bracket by what? The 8y you write outside. So open your brackets. So when 8y divided by 8y, what do you have? You should have a 1. Then plus, now 8y squared divided by 8y, what's your answer? I think it's y. But maybe somebody is not sure. Let's see there. You want to get 8y squared divided by 8y. So how do we get that? So expanding this, you have 8 by y. And down here is 8 by y. So 8 cancels 8, y cancels y. And you're just left with this one y. You're just left with this y. So this y is just the only thing that you are having left here. So this y should come here. This y should come here. So, and that is why you're seeing it here. Okay, C. Having 27abc plus 29ab squared c. So you ask yourself, what is the highest common factor of 27abc plus 9ab squared c? So what should be your answer? My answer is 9abc. That's my answer. My answer is 9abc. Why? 9 is common to 27 and 9. There is a 9 here, there is a 9 here. Or 9 divides 27, 9 divides also 9. A is there, A is there, B is there, B squared is there, C is there, C squared is there. So out of the 2 B's there, you can get 1. Okay, and that's why you write this out. So let's write this out. 9abc, open your brackets, and have this inside. So the next thing we want to do is that I want to divide each of these. 27abc, I want to divide it by 9abc. 9ab squared c, you want to divide it by 9abc. So how does it work? Now, 27 divided by 9, that is giving us already 3. A cancels A, B cancels B, C cancels C. So we are only having 3 left here. Then this addition sign plus. Then 9 cancels 9, A cancels A, C cancels C. But here this is B squared divided by B. Then we are left with just 1B. Okay, the analysis is here. Let's just come up here and this is 9 by A by B by B by C. Just like what we have it here. B is carrying square, so that's why we're having B twice. So this is 9 by A by B by C. That's 9 by A by B by C. C cancels C, B cancels B, A cancels A, 9 cancels 9. And the only thing we are having left is what? It's just 1B. Yes, it's just 1B. So you are having your B here. You're having your B here. So that's the answer. If you open this bracket, you will have this back. Okay, so let's move on and more examples are lining up. We are having 4a squared b squared minus 10a cubed b cubed. So the HCF of 4a squared b squared and 10a cubed b. Okay, let's take a time and just look for the highest common factor to simplify the work. So 2 is common. 2 is common, and just like you can see it, A is common. I'm having 2 A's here common. So I'm having a A and I'm having another A. Alright? Now any B, there's a B here that is common. So I'm having a B. I'm having 2A squared B. And that is what I'll be having there. 2A squared B. And that is what I'll be having there. So I'm having 2A squared B. So opening a bracket for 2A squared B and writing everything here. So divide each of the term by 2A squared B. This divided by 2A squared B. This also divided by 2A squared B. So by the time you are done with your division, opening your brackets, you have to be minus 5A. Close the bracket. So I've been doing the expansion in previous examples. So I just want to believe you should get what I'm doing. So that is that for this example. Now for the next example, I'm having minus 14y plus 28y squared. How does that work? We'll find the HCF of minus 14x and 28xy. And my answer here is minus 14xy. That is what I've decided to use. Okay, so let's come up and let's divide the two terms by our factor. So just 1 here. This cancels this, we're having 1. Because negative cancels negative becomes positive. Now this is positive divided by negative. That's a negative sign. That's why you see it coming up. Now, by the time you simplify what you have here, I think you'll just be left with 2y. Try and expatiate this and just divide. So 14 in 28 is 2. X cancels S, and this y cancels the square. And you're good to go. Now, someone else may decide to avoid this negative in this factor, and that can affect what you have here. So take for instance, let's assume somebody says he's going to be using 14xy. Let's assume somebody says he's going to be using 14xy, just like I'm using it there. And using 14xy, not minus now. Somebody can use this. Now using this now for the division. So you are left with what? You are left with minus 1. You are left with minus 1. Then the positive sign here was, I think, 2r. Okay? So you can probably rewrite as 14xy into 2y minus 1. Into 2y minus 1. Just rearranging what I have in the bracket. This is 2y and this is minus 1. Okay. I think this is becoming enough for a lecture. Just this last one and we'll be done here. So 3 is common here, and I'm also seeing a p common. So I can have my HCF to be 3p. Oh, sorry, minus 3p. Because I can have a minus there, another minus there. So minus 3p is common. Bring it out. So bring it out and open a bracket for the terms and divide the two terms by the minus 3p. What do you have? You are having a p plus 4r. Why am I having a p here? Negative cancels negative here. So I'm left with p. 3 cancels 3. Now this 1p cancels the square. and I'm left with this just 1p. Okay, this negative divided by negative, that gives us positive sign. 3 divided by 12, that is 4, and p divided by p, that is r. That is how I get it factorized. When you open it, you come back to this. Okay, I think this is enough already for a class. So the second aspect of Unit 2 will continue in another video. So if you want to join the video, just click on your next button right now. You have a link to the video or the video suggested up here if you're directly watching on YouTube. Remember to give a thumbs up, give a comment. Probably the background is not okay by you, and I'm too fast. Just let me have your notions or your view about what you are being offered right now, and I will try and work on them. So there is an exercise attached to this video. Get to the description box. Please attend. Any question, I'll be there to attend to you. If you need a rest, you can rest. And if you think no, you can continue with the large expression from which the second video will continue. Just click on the next button and you'll meet me there. Thank you.